Alright folks, here we are in the beginning of chapter 3. Now this entire chapter is all based upon this diagram right here. You have two lines and they're being cut by a third line. Now normally these two lines are parallel. I understand they're not parallel right here, but for the rest of the chapter, most of the time L and M are going to be parallel to each other because special things happen when those two lines are parallel. Well, first thing here, you have a line cutting through it. You see it's labeled T. And right here it says that line T is called the transversal. So the line that cuts through the other two lines is always the transversal. It's not necessarily the one going up and down. Sometimes it'll be going horizontally. But the line that cuts through the other two lines is the transversal. Now when this happens, you see you have 8 angles that are being created. When you have two lines being cut by a transversal, you create these 8 angles, and they have special pairs of angles. The first kind is called alternate interior angles. You see we have alternate and interior, so we have to figure out what both of those words mean, and then put those two ideas together. So interior means between the two lines, between L and M. So our interior angles here are 1, 2, 3, and 4, because they're below L and above M. So interior are 1, 2, 3, and 4, but now we need to know what it means by alternate. Alternate means they're going to be on opposite sides of the transversal, and they can't be right next to each other. Because if you're looking at 1 and 3, I understand they're on opposite sides of the transversal, but there's adjacent angles. We already have a word for that, so we don't need a new word. So the alternate interior angles are going to be like 1 and 2, because they're on opposite sides of the transversal and not right next to each other. So angle 1 and angle 2 are our first pair of alternate interior angles. The second pair is created is angle 3 with angle 4. So that's going to be our second pair. So that's what it means when we say alternate interior angles. The next group is same side interior. Now you see we have interior there, so we're still talking about 1, 2, 3, and 4. But this time they want same side interior. So same side means on the same side of the transversal. So 2 is an interior angle, and on the same side of the transversal is 3. So angle 2 and angle 3 make a pair of same side interior angles. Another pair, you see you have angle 1 here is interior. It's going to be paired up with 4 because it's on the same side of the transversal and they're both interior. So angle 1 and angle 4 are a pair of same side interior angles. And all these vocabulary words here we're learning, they all deal with pairs of angles. Like we have vertical angles. Like angle 5 cannot be a vertical angle all by itself. It has to be a vertical angle with another angle. So these pairs are the same way. They have to be 2 angles together. Now corresponding angles, that term really doesn't give you a whole lot of help. Because you have alternate interior, you could sort of piece together what those words mean. The corresponding is just something you have to remember. When you figure out corresponding angles, you look at this group right here as a cluster or a neighborhood or a group of angles, and this one down here is another group. To be a pair of corresponding angles, these angles have to be sitting in the same spot for their particular group. So what I mean by that is this. You look at angle 5. Angle 5 is in the upper left angle of this particular group here. So it's going to match up with the upper left angle in this particular group, which is angle 4. So angle 5 and angle 4 are our first pair of corresponding angles. For a second pair here, we'll look at angle 3. Angle 3 is in the bottom right for this cluster, which means it has to match up with the angle that is in the bottom right of this cluster down here. So this one here, the bottom right, we're looking at angle 8. So angle 3 and angle 8 together make a pair of corresponding angles. Corresponding angles are a little different because they actually have 4 pairs created, not just 2 like alternate interior or same side interior. So there's actually 4 pairs of corresponding angles. So what you want to do right now is pause the video and figure out the next 2 pairs of corresponding angles, because that will be our answer to example 1. So pause your video now. Alright, our corresponding angles. We have not dealt with angle 6 yet. Angle 6 is in the upper right, so it's going to match up with angle 2. Angle 6 and angle 2 are a pair of corresponding angles. And the last pair is going to be the two that we have not yet talked about. So that's going to be angle 1 in the bottom left and angle 7 in the bottom left. So there's our 4 pairs of corresponding angles, and that is our answer to example 1. Our first postulate here for chapter 1 says it's the corresponding angles postulate, so you know it's going to be dealing with corresponding angles. It tells you if a transversal cuts through 2 parallel lines, then corresponding angles are going to be congruent. You see over here on our diagram, we're starting off by already knowing that they're parallel, because that part comes from the first part of the postulate. That's the hypothesis. So you know already that they're parallel. And now the rest of that postulate tells you that, well, then the corresponding angles have to be congruent. So you look at our diagram here, angle 1 and angle 2 are both corresponding because they're sitting in the same relative location for each group, upper right, upper right. So based on this setup here, you know the lines are parallel. Here's your transversal. Angle 1 has to be congruent to angle 2. A similar kind of idea here for alternate interior angles. It tells you if you have the same kind of idea, you have parallel lines being cut by a transversal, then alternate interior angles are also going to be congruent. And we're trying to save some space here, so we have this diagram that's being used for Theorem 3.1 and Theorem 3.2. So down here you have parallel lines A and B. Here's your transversal T. And our alternate interior angles are going to be angle 1 and angle 3. So because of the fact we know that they're parallel, our theorem tells us that 1 has to be congruent to 3. So angle 1 is congruent to angle 3. Next theorem, using the same diagram, is something about same side interior angles. So it tells you that if you have parallel lines, and here's your transversal, then same side interior angles are going to be blank. Well, it's tempting to say congruent because we just filled in congruent for the last 2. But if you look at the same side interior, angle 1 and angle 2 are same side interior. They're on the same side of the transversal, and they're both interior. So they are same side interior angles. You see, angle 1 is clearly acute. Angle 2, however, is obtuse. So there's no way we want to put the word congruent there, because it can't be equal. There's no way an acute angle is ever going to match an obtuse angle. So they have to have some other kind of special relationship. And it turns out when you have this situation, same side interior angles are going to be supplementary. So that's what we want to put there. So based on a little picture here, we have parallel lines. We know that the measure of angle 1 plus the measure of angle 2 has to equal 180. So here we have corresponding angles are equal, alternate interior angles are equal, but same side interior are supplementary. And this is all based on the fact that those lines have to be parallel. As soon as those lines are not parallel, these angles will no longer have those special relationships. Let's turn the page. Right, example 2, it wants you to prove Theorem 3.1, and that theorem said that if you have parallel lines cut by transversal, then alternate interior angles have to be congruent. So when we're trying to prove a theorem, and you're trying to figure out what is given and what needs to be put in the line where it says prove, the general approach is this. Whatever comes after the word if goes in for the given. In other words, we called that the hypothesis earlier in the year. So you're allowed to say that the lines are parallel. And over here you can see, you can also get that from the diagram. A and B are parallel because we have our little parallel markers right there. Those little arrows meaning that the lines are parallel. So what's given to us is the fact that line A is parallel to line B. Now what you fill in for prove, or what you're being asked to do, deals with the conclusion of the sentence. It says then alternate interior angles are congruent. So we're supposed to show that alternate interior angles are equal. So you look over here and say, well, which one of those numbers are alternate interior angles? It's got to be 1 and 3 because 4 is not interior. It's on the outside of those two lines. So it is an exterior angle, not an interior. So if we're trying to show alternate interior angles are congruent, in this case, we're trying to show that 1 is congruent to angle 3. Alright, as you may remember here, we want to start off in our little proof with the information that is given, because we cannot use this information in our proof until we actually put it in the proof. So our normal starting spot is to start off with what is given. In this case, line A is parallel to line B, and there everyone's favorite reason or favorite justification is given. Well, we have to build off that idea now. Remember, we're trying to show that 1's equal to 3. You look over here at our diagram, they've given you 3 numbered angles, and typically they will not give you information you don't need. So the fact that they're using that 4 right there means we're probably going to use it. So you say, well, how does 4 relate to those other angles? Well, 4 and 3 are a pair of vertical angles, and one of the theorems we've already learned said that vertical angles have to be congruent. So we know for sure that angle 3 is congruent to angle 4. How do we know? Well, it's because of that theorem. It's called the vertical angles theorem. That's the theorem that says the vertical angles must be congruent. So you can write vertical angles are congruent, or you could write vertical angles theorem. You remember even further back, we had a list of things you're allowed to assume, and a list of things you're not allowed to assume when you look at a diagram, and vertical angles was one of the things you're allowed to assume. 3 and 4 look like they're vertical angles, so you're allowed to assume that they are. And our theorem tells us that they have to be equal, so we know for sure that 3 is equal to 4. Well, how does 4 relate to some other angles? Well, you tell 4 and 1 are a pair of corresponding angles. And anytime you're trying to prove a theorem, you can use any of the theorems that come before it. And one of the theorems or postulates that came before Theorem 3.1 was the theorem that was the postulate that said that corresponding angles have to be equal. So 1 has to be congruent to 4 because of that postulate. Now you can write out that postulate if you don't remember the name, but that one happens to be a nice, easy to understand name. That is the corresponding angles postulate, so it's easy to remember. So we're going to put down the corresponding angles postulate. That's the one that said as soon as you know the lines are parallel, and we know that in step 1, as soon as the lines are parallel, then corresponding angles have to be equal. We're moving along here, and remember we're trying to show that 1's equal to 3. We're going to keep working on the left here until we show that 1's equal to 3. Well, we said that 3 is equal to 4 and 1 is equal to 4. Well, if both of these angles are congruent with angle 4, that means they have to be congruent to each other. So if they're both equal to 4, they have to be equal to each other, and sure enough, we just showed that 1's congruent to 3. Now we need a reason. Well, you look up here, and you could explain this by saying that we got rid of angle 4 and replaced it with an angle that we know is equal to it. Put it in its place. So that right there is the substitution property, because we're getting rid of one thing and replacing it with something else that we know is equal. And there we go, we're all done. We start off by knowing that the lines are parallel, and our conclusion is the fact that alternate interior angles are equal. And the fact that we did not use any degrees anywhere in here in the proof here shows that it works not sometimes, but all the time. We're going to stop right there since we're partway through section 3.1, and we'll pick it up next time. Talk to you later.